On GitHub, academic course materials rarely go viral. Yet, a highly specialized repository called Dive into LLMs sits at over 32,000 stars, completely defying the typical engagement metrics for a university syllabus. This massive backing from the developer community points to the unique origins of the project. It was developed at Shanghai Jiao Tong University by a research team led by Zhang Ruosheng. Most introductory artificial intelligence courses safely guide you through basic probability and standard neural networks. This syllabus bypasses the basics entirely to deliver raw implementations of extreme edge case architectures. Look at the actual table of contents. It provides raw, executable code for jailbreak attacks, methods specifically engineered to systematically bypass a language model's safety guardrails. Right next to it, you will find fully functional scripts for LLM Steganography, a technique used to secretly embed hidden messages within standard AI-generated text. Security researchers universally classify these specific techniques as weaponizable attack vectors. They are the tools used to exploit models, not just build them. This collection of scripts provides a public look at the specific alignment and attack methodologies usually restricted to closed-source enterprise research labs. The popularity of this repository exposes a deep frustration among machine learning engineers who are trying to upskill in an increasingly saturated market. Traditional academic pathways over-index on dry mathematical proofs, leaving engineers without the practical implementation skills needed to actually write the code. Conversely, the vast majority of online bootcamps take the opposite approach. They act as shallow wrappers, teaching users how to call the OpenAI API without understanding the underlying mechanics. This visual comparison highlights the gap. Instead of simple API calls on the left, this syllabus drops you into the raw, Python-native environment on the right, providing the hands-on control that engineers actually require. It forces you to build complex systems entirely from scratch. You write the exact reinforcement learning loops, specifically PPO-based RLHF, that align models to human feedback. By removing the abstractions, the repository provides the architectural blueprint for engineers who need to train and align foundational models themselves, rather than just prompting someone else's. To achieve this level of technical depth, the curriculum relies on a strictly modular architecture designed to take a student from raw data to a deployed agent. The entire foundation is built on a series of interconnected Jupyter Notebooks. Each script isolates a specific component of the model pipeline. The progression is steep. You move from basic pre-trained model fine-tuning directly into distilling complex mathematical reasoning models, like constructing a miniature version of the R1 reasoning engine. The repository's code moves beyond theoretical mathematics by including a specific hardware optimization layer woven directly into the training loops. This display shows the technical specifications for the Ascend 910 and 310 chipsets. The repository features a deep custom integration with this Huawei Ascend ecosystem as its primary hardware target. Looking at this physical Huawei AI processor, we see the engineering reality. The curriculum teaches developers how to write code that bypasses the standard NVIDIA software stack in favor of specialized, localized hardware. This forces a rigorous, hardware-aware approach to LLM training. It requires the developer to understand exactly how memory and compute are allocated, rather than relying on the abstract, infinite compute of cloud providers. Moving past the hardware optimization, we have to audit the sections the creators label as hidden gems, the specific alignments and security tools absent from standard university curricula. The first of these is LLM Watermarking. In the context of this repository, it refers to cryptographic techniques used to track machine-generated text. This diagram illustrates the mechanism. The Python scripts manipulate the model's token probabilities to embed human invisible text markers directly into the generated outputs. The curriculum then details the exact mathematical verification process required for a receiver to analyze that text and detect the watermark with statistical certainty. From watermarking, the syllabus makes a logical leap to LLM Steganography. This is effectively the digital equivalent of invisible ink. The notebooks provide the methodology for fine-tuning models to carry specific, hidden data payloads within their standard conversational answers. The true value of this repository lies in explicitly open sourcing these advanced security alignments, pulling them out of private labs and offering them up for public dissection. But when we pivot from the theoretical syllabus to the actual codebase, the reality of deploying this repository becomes clear. Despite accumulating 32,000 stars, the repository suffers from an extreme lack of codebase maintenance. Over its entire lifespan, the main branch has recorded a surprisingly low velocity of only 73 total commits. A quick audit of the real-world community feedback on the GitHub issue tracker reveals exactly how fragile this code is in practice. Issue number 13 exposes a severe hardware incompatibility for Apple users. Attempting to utilize macOS Metal performance shaders for acceleration on Apple Silicon results in fatal code execution failures. Then there is issue 28, which flags foundational logic bugs sitting directly inside the data pipeline. The primary load data function, the very first step for training, cannot even execute without crashing. It requires manual rewrites of the source code just to ingest information. Furthermore, issues 26 and 14 catalog a trail of missing critical assets and broken links. Vital multimodal datasets have been deleted from the source, and the core project zip files simply cannot be downloaded. These are rudimentary execution failures. They completely bottleneck the high-value conceptual architectures promised in the syllabus, halting progress before the training loops can even begin. The data shows that while the repository functions as a comprehensive academic framework, the lack of code maintenance makes it unfit for production environments. Beyond the broken code, the very existence of this repository in the public domain forces a broader conversation about industry implications. This material carries the weight of institutional research from Shanghai Jiaotong University rather than the unverified suggestions found on anonymous forums. That creates a conflicting duality. The syllabus operates simultaneously as a rigorous educational tool and a highly specific tactical manual. We have to question the ethics of distributing raw, copy-paste code designed explicitly for jailbreaking live language models. We also must examine the specific security risks of standardizing steganography payloads. This code openly teaches developers how to let models hide unauthorized data within seemingly harmless, fluent conversations. This presents the central dilemma of modern machine learning. Is publishing this offensive code actually democratizing AI safety, or is it simply arming bad actors with the blueprints for exploitation? The availability of this code demonstrates how quickly advanced offensive research can transition from a university classroom to an open-source download. If this saved you time, hit subscribe. We review tools like this every week, so you're always ahead. Now, if you liked this deep dive into LLM engineering, you're going to love our breakdown of AutoGPT's new architecture. Open source moves fast. Builders must adapt, or they will be left behind.